Hi, good morning, and welcome to this edition of Boundaries Webinar Wednesdays. My name is Shaish Mbore, and I will be taking you through Creo Parametric and Mathcad Prime integration. And so basically, we're going to go through a quick PowerPoint presentation, and then we'll dive into the integration. And first off, I'll just do a quick introduction on boundary systems and who we are. And then I'll go into talking a little bit about Mathcad, and then we'll talk about the different use cases for which the integration was developed, and I'll go into a live demo of the functionality, and after that we'll have a question and answer session. So just a quick note on boundary systems. And so boundary systems is a technology leader in the field of product development consulting using CAD and CAE software. We do everything from CAD design and consulting, and then data management to help you manage that data, and then also simulation as well on those CAD designs, and so that way you can ensure that you're getting the best possible product. And we also do product lifecycle management as well. Now, just the last bragging slide over here. This just basically talks about how we have been voted as one of the top 100 fastest growing companies in Northeast Ohio for the last 3 years consecutively. And so when it comes to being recognized for what we do in our field, we've definitely gotten a few awards, and we do it very well. Okay, so just a quick introduction on Mathcad. Now Mathcad, usually whenever you're in the design process, you usually from start to finish, there are many different things that become inputs into your design. And so, for example, getting data from reference materials could be, or reference manuals could be one source. Another could be, having computer programs or Excel spreadsheets, where you have some data stored in there. Or another could be, a physical test where you strap a data acquisition device to a particular test object on a test stand, and you get 2,000 data points out of that device. Well, it exports that to an Excel spreadsheet, and you need to mine or manipulate that data. And not only that, but you can also have word processing documents. So Excel, a Microsoft Word, requirements sheets, spec sheets, steps or instructions, or even manuals and things like that. The beautiful thing about Mathcad is that Mathcad combines all of those different information sources into one easy to use and format document. And so that's what makes Mathcad that much better than anything else when it comes to engineering communication. It's because it can, first off, help you format any math that you do in a very easy to format natural math notation. You can also combine best-in-class, word processing capability, and also adding pictures, creating math, and also not shown in this screenshot is also being able to connect it with Excel and being able to import very huge matrices, in this case over 2,000 data points, again from that data acquisition device, and then being able to manipulate that data. And so Mathcad is basically a one-stop shop when it comes to engineering communication for the design engineer. Now, a quick word on the integration. The integration comes standard with every install of Creo 3.0 from the M30 datecode and above. And so basically all you have to do is to install Creo 3.0 M30 datecode, and you check a box that says you're going to install Creo 3 M30, and another box that says you're going to install Mathcad Prime 3.1. With both of those boxes checked, once the install is done, both installations are already integrated. There's no other setup required. So that makes it very easy to set up. And once you're done with that, you then get into the integration here. Now, one of the typical use cases that this was designed for is to document design decisions. So typically, whenever you build a design, you either have to, describe what you've done to any other engineer in the company that's going to use your work. So that way, whenever I'm using Jim Bob's model, I want to make sure that I can understand what Jim Bob was doing, why he did what he did, why he made feature 2 dependent on feature 1, why he made two dimensions, constrained together, or could just be something as simple as, okay, if I change, this one, object, what else in the design will be affected by just that one change? Being able to type out and use the word processing capability of Mathcad to document and say, these are the steps and this is what I did, makes it very easy to pass on that knowledge and retain it within the model. Next, we have the ability to perform analysis-driven design. And in that case, that will be one where you have certain formulas that inform your design, and the results of those formulas you then want to drive into Creo and have Creo be influenced by that, or have Creo update or make the model bigger or smaller based on the results of those formulas. And again, because of Mathcad's powerful mathematical engine, you can define equations, you can define integral, and many other kinds of mathematical equations. And again, Mathcad can solve all of that, generate an output at the end that you can then pass into Creo and have that drive your Creo design. Now, not only can you do that, you can also use Mathcad's intelligent solve blocks and logic blocks to do more than just solving equations. And so in the bottom right screenshot, you'll notice there's a maximized text there that's in a red box. Well, with that, you can use Mathcad's intelligent functions to not only solve for a specific value, but also maximize or minimize certain equations, so that way you get the best performance for your particular model. So in this particular example, we're actually going to walk through this. We want to maximize a particular ratio that ensures minimal heat loss and maximum engine efficiency for that 6-cylinder engine right there. And so again, by being able to call on that maximize function, we're able to get the optimum dimensions we need to design our engine in this case. And then finally, another use case scenario that this was designed for is basically to perform design validation. And so this is usually a case where you have your design in Creo already done, and now you just want to take those existing dimensions in Creo, pass them to Mathcad, and have Mathcad run sort of a what-if check analysis. So if I use these dimensions based on my Creo model, am I within my limits? Am I where I want to be, or am I way off? So an example of that, based on the crankshaft assembly at the top right corner there, if I know I want my compression ratios to be between 10 and 15, I can design my crankshaft assembly as I want it to be, and then once I'm done, pull that into Creo and then run an analysis to say, okay, based on what I just designed, is my compression ratio between 10 and 15, or am I way off and I have to go modify my geometry to meet that? Now, at this point, we will pause for a second and go through a live demo. So I'm going to switch my screens here. Okay. So the first model we're going to look at is this right here. This is basically an assembly of a clutch, right? And typically, what you want to do, at least in the way this is designed, you want to insert multiple discs in there, and based on the amount of torque that clutch assembly is going to experience, that will determine how many discs we will need to have in there in order to have a good amount of surface area for friction as everything spins. And so again, the number of discs is dependent on the input torque. Now we have some constants already defined in terms of the the inner diameter and the outer diameter and things like that based on the geometry. But now what we want to do is optimize the number of discs. And so in order to do that, we will basically go to the Applications tab. And right here, you'll notice there's a PTC Mathcad button that's already there. And now, in the case where you want to connect this to a completely new worksheet that you start typing on the fly, you can hit on the Open or Create Worksheet. But in this case, we're going to connect this to an existing worksheet that's already been defined and formatted. And so we'll use the Insert Worksheet. We're going to pick that one. Yeah. Now, the worksheet opens up, and you'll notice basically it's basically calculating how many disks we need in that clutch assembly. Now we have different areas where we formatted word processing. We have pictures. We have formulas as well, and we basically give it here a torque value, and it runs through some calculations, and eventually comes out at the end. It spits out one value for the number of disks that we need to have inside of the assembly. And so now, in order to start the integration, what we're going to do is we're going to tell Mathcad what we want these things to be. So we're going to take on this our region right here, and we're going to tell Mathcad that this is going to be an output region. So basically, it's going to take the result of that and push it out to an external application, in this case, Creo Parametric. And the other thing we'll do here in this input and output designation is we're going to specify the alias, and that is useful because that alias ends up becoming the name of that variable once it's passed into Creo. So I want to make sure that it has a name that I'm able to understand and identify. Next, we'll go up to the top of the document and then tell Mathcad, okay, this field right here, we want that to be an input field. So we're going to wait for Creo Parametric to pass in some information from Creo into Mathcad. And once we have those two, final step is to then save and push. And so it saves the document and then pushes the values to Creo Parametric. Now we'll switch back to Creo, and in here what we'll do is head into the Relations box, and this is where we can tie in both of those parameters together. Now if I look for, in this case, all the parameters in here, let's see. Scroll down. Yeah. So right here we'll notice there are multiple QIN parameters, but there's this one right here. We'll notice it's 430, and Mathcad tells us, or Creo tells us, it was an input from Mathcad. And so Mathcad pushed in that value into Creo, and that we know that's an input region. Now what we're going to do is we're going to tie that to the Creo parameter that specifies the input torque, which in this case is this second one right here with the 670 value. And so it's just as simple as telling Mathcad, okay, or telling Creo, let's take this parameter, one from Mathcad, and whenever you have that, you're going to make that value equal to the value of this second parameter here. Insert that to Relations. Okay. Next is we're going to look for the number of plates parameter. Okay. Right here, and just like before, this end plates is the parameter that was passed in from Mathcad, and that's with the output region. And then this is the parameter that controls the number of disks inside of Creo. And that's, in this case, currently defined as 6. And so we'll go ahead and tell it, okay, for this particular case, we'll take the Creo parameter, insert that, and we'll say that parameter is going to be equal to whatever Mathcad spits out for the value of n plates. And so we have those two currently defined, and we'll say OK. Before we do that, we'll verify our relations. Everything verified successfully, and then we'll say OK. Now, once we do that, Creo tells us, OK, we need to regenerate, and when we do, tells us, right over here in the notification center that there's an outdated Mathcad document. That's because the input torque here doesn't match what's currently in Mathcad. So now we go ahead and say, okay, let's go to that Mathcad document. Now, the other thing about this, I'll mention this now that we're here. Once you insert or embed a Mathcad worksheet into a Creo design, you always have this glyph over here, top right corner, and that basically links directly to the Mathcad worksheet. So immediately I click on that, it opens up the Mathcad worksheet. And so that way you'll always be able to access that, and it basically travels with the existing Creo design. And so in this case here, now that I'm here, I'll notice this is currently set to 430, and we'll go ahead and say, well, let's update the inputs. And so once I update the inputs, it then realizes, okay, the value from Creo is 670, and so I'm going to pass that in. And now it runs, immediately it receives that, it runs through all of the calculations, and it says, okay, now the number of plates you need is 6 plates in order to support the 670 input torque. Now I'll save and push the values back into Creo. And now when I come into Creo, I'll notice that the Regen Manager in Creo is yellow because it knows, okay, something has changed, and I want to reflect that change because currently what's on screen doesn't reflect that. Now, I'll zoom into the model a little bit, and you'll notice at the those blue disks right in the middle there are currently 4 of them. When I regenerate, notice Creo goes ahead and adds 2 more to that. Just takes the value from Mathcad and updates the design immediately. Now, another case could be, okay, what if we save a copy of this particular assembly now? Now it's just as simple as, if customer B comes to us and says, oh, our input torque is 220, not 670. Well, it's as simple as saving a copy of this assembly and then going into our torque value and saying, instead of 670, let's make that 220. Say OK. And now once we regenerate, that tells Mathcad, okay, you're out of date. And so we can switch to Mathcad and update the inputs. Once we update the inputs, that then tells us, okay, you need 1 plate now to support the 220 Newton meters of torque. And now we'll go ahead and push this value back into Creo. And when we go to Creo, we'll notice when we regenerate, now Creo updates and the geometry reflects 1 disk being used in there. And so it's very quick and easy to perform some analysis-driven design changes when you connect Creo and Mathcad together. Okay. Now the next example we'll show here is this over here, and that's with the engine block. And basically, actually, not the engine block. This is a crankshaft assembly. So basically, for a 6-cylinder engine, and what we want to do is twofold. First, we'll connect this assembly here to its Mathcad worksheet, and then I'll explain. Okay. So what we want to do here is twofold. So first off, we're designing this engine block and this crankshaft assembly, and one of the things we want to do is to run a quick validation check. So our compression ratio, we want that to be between 7 and 9, and we want the total engine displacement to be between 3.25 and 3.3 liters. And so now what we want to do is we want to take the values currently in Creo and pass them into here. And those values we want are these for these two regions right here, so the diameter of the bore and then the radius of the crankshaft. Now currently, those two just have a placeholder value of 1, and we're going to assign those as input regions. And now basically once it receives that information, Mathcad will run through a lot of calculations and optimizations, and at the end, it's going to come out with basically the requirements verification right here for the compression ratio and the engine displacement. And so if we go back to the top, we'll see here, okay, Mathcad has received those two variables as inputs, and we'll save and push this to Creo. Now when I click to Creo, we'll go into our relations box, and this is where we're going to connect both of those together. Now, before I do that, I actually have to get a Creo parameter for the radius of the crankshaft region. So what I'll do here is I'll hide that, and then let's measure the distance over there. Now, what I'm basically doing is I'm measuring the distance between the offset of the crankshaft there. So basically the center to center distance of those circles. And so that then tells me the crankshaft radius. And now I'll go ahead and save that. Okay. 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 Now we can then tie those quantities together. And so right here in the relations box, we'll go ahead and specify that. Now, first off, because in this particular case, we're going to be passing the diameter and radius, both of which are units dependent. Both of those, have to be in specific units. In the relations box, we'll tell it over here that our relations are unit sensitive, so that way it knows to convert those units. And then now we're just going to go ahead and click on this here and say, so the D-bore, insert that to relations. We'll notice that is a parameter that comes from Mathcad as a source. And we're going to say that is equal to the diameter of each piston here. So, yeah. And then next, we're going to insert radius of the crankshaft, and we'll say that is equal to the distance, so which is this parameter that we created. So that's the crankshaft radius that we just measured. And we'll insert that and say those two are equal. Now that we're done, we'll verify our relations, and when everything is happy, we say OK. Now it immediately notices that there is a out-of-date Mathcad worksheet, and so it tells us that right here in the notification center. And so now when I flip to Mathcad, again using this glyph, currently the placeholder values here are 1. When I update the inputs, it updates with the dimensions from Creo and immediately runs through all of the calculations. And it comes over here to the bottom where I can now quickly see my compression ratio is 7.053, and I wanted that to be between 7 and 9. And so I can quickly see here that I'm within that range, even though I'm on the low end, but I'm where I want to be. And then also my engine displacement in this case is 3.3 liters, which is on the higher end because I want it to be between 3.25 and 3.3. But again, it's a thumbs up. I am where I want to be. And so that's one way of using Mathcad as a quick, validation check for your design. Another step from there is to then pass values back into Mathcad. And so what we're going to do, the second part of this here is we're going to designate these two regions here that are green as output regions. And the reason we're doing that is because right here at the top, we also want to maximize a certain relationship here. This is basically the internal volume within the combustion chamber and the surface area of that combustion chamber. So typically, the bigger the volume, the more pressures you can get and the more power you can get out of the engine. And also, the bigger the surface area, the more heat loss you get, and so the less the gas can expand. And so usually you want a case where you have maximum volume for a minimum surface area. So you want to reduce the amount of surface area while retaining as much volume as possible. So that way you can maximize your efficiencies in this case. And so that's a ratio that a lot of designers doing this kind of work usually would pay attention to. And now we want to maximize that. And so Mathcad is going to run through some calculations. And at the end, there's a maximize logic a function that's called, and that basically tells it to maximize that that equation for those for certain given dimensions. And I'll show what those dimensions are when we get back into Creo. Basically, here we want to rename our aliases just so that we know what they are. This bottom one, this here is going to be HPH, and then this next one here is going to be RPH. Okay, and then we'll save and push the values back into Creo, and the push was successful. Now, when we flip back into Creo, what we want to optimize are the dimensions of that spherical cap at the top right here. And so that is basically a spherical revolve, and that serves as a spot where the air-fuel mixtures, are sprayed into, and then the explosion happens in the engine. And we want to optimize those dimensions to get the maximum volume with the smallest surface area. And so once again, like before, we'll go into our relations box. And in here, we will do a couple of things. Okay. So, let's see. Okay, there we go. Okay, so for that spherical feature at the top, we can tell it, okay, we have that dimension there, that's the radius, so 30, and we'll say that should be equal to the Mathcad output of RPH. So Mathcad tells us the optimal radius, so we'll insert that to the relations. And then we'll say the height of this. Let's do this again. Okay, there we go. We'll say that height over there at 5 is going to be equal to the height value that Mathcad tells us for that conical shape. Or sorry, the spherical shape, I should say. Then we'll verify this successful. We'll say OK. Okay. So now that we have that, we'll notice the regeneration manager is yellow, so it's basically telling us something has changed, and what's on screen currently doesn't reflect that. And so if I zoom into one of the piston heads over here, just so we can take a look at what's going to happen, you currently see how that spherical cap is. When I go ahead and hit Control G to regenerate, we'll notice how the diameter gets bigger and the depth gets smaller. And so again, we're maximizing that ratio of surface area to volume, and again, giving this the optimal dimensions it needs based on what the Mathcad output is. So again, that just goes through another use case scenario of using Mathcad, where you're using it to do some design, analysis-driven design, basically, where you're running calculations in Mathcad and then passing that into Creo Parametric. And so at this point, we will move it over to questions and field some questions. Okay. Now, one of the questions that I typically get whenever people ask this is, or whenever I present this topic, is what is, how does Mathcad behave, with the existing worksheet that it was tied to? So, in other words, if I, can I, once I connect the two, does it change the existing worksheet that I have whenever I make edits in Mathcad? And also, what happens if I move that existing worksheet from wherever it is in my folder system? Does it break the model inside of Creo? And whenever if I switch screens here and I go back to my first screen, just so that way you can see that. So in here, you'll notice what I have here is currently the crankshaft assembly Mathcad worksheet, and these two yellow cells here are the input regions. Now I'll go to my disk and I will open that same worksheet that I inserted into Creo, and you'll notice that over here it's called piston head profile, and those two areas are not input regions. And the reason for that is basically the moment you insert a worksheet into Mathcad, Mathcad will make an exact copy of what is on the disk and store it inside of the Creo part or Creo model. And so in this case, it stores it inside of the crankshaft assembly part, and so, crankshaft assembly file. And so we'll notice over here at the top, the path leads to a .asm extension, not a Mathcad extension. We'll notice that the icon also looks like a Creo assembly icon, and the changes that we made on the Mathcad worksheet inside of that model are not reflected in the version of the Mathcad worksheet that is stored on the disk. And so the moment you create that, the contents of that live inside of that Creo model. Another way to illustrate this, so I can show this really quick here. So I'll change my working directory to this new folder called test. And what I'll do is I will close everything, and then I'll open, I'll make a new file. Call this, say, a new part. I'll call this my test part. Okay. Now, the very first time I saved test, I press Control S to save that. It saves that into the test folder. I'll say OK. And if I go to that test folder, I only have one entry in there, and it's currently 43 kilobytes in size. Now I'll go back into Creo and insert, or I guess I'll create a new Mathcad worksheet in this case for the test folder, or sorry, for the test part. And I'll go back into Creo here, and let's save that. So File, and then Save. And so it saves the Creo part, but when I go to my folder, I'll notice I don't see any Mathcad document in here. And the second thing I notice is that the second version of my Creo part is now 48 kilobytes. And so it's grown in size, even though physically I did not make any changes within Creo to this part, to this part model. And that's because it created the Mathcad document and stored it inside of the Creo part itself. That's where the Mathcad integration document lives. And so as a result, it's bigger, and it doesn't live outside of that document. And so because of that, it's impossible to have a case where you move the existing Mathcad worksheet from your computer and the Creo part cannot find Mathcad because the Mathcad worksheet that it uses lives inside of the Creo part. Now, another question typically is, okay, based on that, what then happens if I remove the worksheet? So in this case here, you can also go down here and say remove worksheet to get rid of the embedded worksheet in Mathcad. And if you do that, your Creo design does not fail. What it'll basically do is it'll leave the worksheet, or it'll leave your Creo design at the last known parameter or input values that it received from Mathcad. And so it will not fail immediately. It'll just leave it at that last known design state. And then if you want to update any changes, you would have to embed the Mathcad worksheet and run the changes through Mathcad if you want, if it's going to be a mathematical change that you make through Mathcad. Now, another question I typically get is, if the Mathcad document lives inside of the Creo model, what if I want to, send that Mathcad document off to a coworker? How do I then? The coworker doesn't have Creo. How do I do that? Well, if we switch to the Mathcad document here, in this case it's currently empty, but we can still use it as an example. You can go here and tell Mathcad to save as, and then save a copy of that. And so if we do this here and say save as a worksheet, it will save an exact copy of what is inside of that Creo model and save that to its own independent Mathcad worksheet file. And so that independent file I can send off to any customer or coworker as I see fit. Now, that basically covers the frequently asked questions and all of the webinar content. And so at this point, we will end the webinar. Thank you very much for watching this, and please stay tuned to Boundary Systems as we come out with more webinars and see how and present to you more information about PTC and our other products that can help you achieve higher levels of success. Thank you. Bye.